Also, make sure you're following along in your book, Mister. There's not a lot of writing on your end, but I do want to explain this. Okay, so I'm going to zoom in a little bit. So it says when the sun makes orbit around the center of the Milky Way, it travels at 2.025 times 10 to the 14 kilometers. The orbit takes about 225 million years. At what rate does the sun travel? Write your answer in scientific notation. So let me read that again. When the sun makes an orbit around the center of the Milky Way, and I'm going to draw a little picture here, okay? They're saying that the sun, right? And let me draw another little picture. This is the sun, right? And it makes an orbit around the great big Milky Way, okay? So just imagine a big, huge Milky Way, right? And it makes an orbit somewhere around this thing, somehow, some sort of way, right? So the sun is moving around within the Milky Way. And that's not the best picture, but I just want you to get the visual, right? So, well, how is it doing it? Well, it travels. The total distance is 2.2 2.025 times 10 to the 14 kilometers. So that's a distance. The time that it takes is 225 million years. And then it says, at what rate does it take? Does the sun travel? So here is, and I got this sideways. That's funny. That's why it wouldn't work right. So remember that distance is equal to a rate times time. When they say what is the rate, algebraically we want to get r by itself. RT means r times t. So we divide both sides by t. The t's will cancel and I'll get the rate is equal to the distance divided by the time. So what we know is that the distance is equal to 2.025 times 10 to the negative 14. I'm just going to get rid of this little thing here. Kilometers. And then the time, t, is about 225 times 10 to the 6. Now, you guys don't know this, but whenever we say million, million is the same as 10 to the 6. Right? Now, that means that my time should be converted if I move the decimal 2 spaces this way, 2.025 times 10 to the 8th. So how do I figure this out? So it says, well, I'm going to have to take the distance and divide it by the time. So let's figure that out. So it says the answer to the number of kilometers per year the sun travels around the Milky Way. First, we got to set up a division problem. The rate is equal to the distance divided by time. That's what Mr. Adams said. Okay. Step 1, write that in. So the rate is equal to this stuff divided by this stuff. So let's take our handy dandy calculators, okay, and see what we get for an answer. So this is a perfect example of scientific notation. So I'm going to say 2.025 times, you know what we should do? Let's put this in parentheses. Actually, let's hit the math button and make it into a fraction. Right? So hit the math button, move over to the fraction menu like that. Right? You guys remember that? Raise your hand if you don't, and I'll come by and show you. Hit enter. And now I'm going to delete all that other stuff, but I'm going to put 2.025 times 10 to the, what was it? 14, I think it was. Yeah, 14 kilometers. 10 to the 14. Oops. 10 to the 14 divided by 2.25 times 10 to the 8, I said, right? Okay. Now I'm going to come over here because Mr. Adams has got to delete that. So let me get rid of all that stuff. All right. I'm going to hit enter. I'm going to get like this crazy number. What's that? About 900,000? Well, it's 900,000 kilometers per year, roughly. All right. So let's see what they say. So they said, we'll do the math. But they said, look, another way you could do the math. By the way, let's write our answer down just to see. So we said that 2.025 times 10 to the 14 kilometers divided by 2.25 times 10 to the 8 years, right? I'm going to get, I said it was about 900,000, right? 900,000 kilometers per year. And if we do scientific notation on that, we would get 1, 2, 3, 4, 5. So it'd be 9 times 10 to the 5 kilometers per year, if I did my math right. Okay. So, but they said, hey, you could get that answer this way. Take just the coefficients of the scientific notation. In other words, take just this and divide it by this. And when you do that, you get 0.9. Then they said, take this and divide this by this. And we know the shortcut for 10 to the 14 over 10 to the 8 is going to be the same as 10 to the 14 minus 8, or 10 to the 6. So you'll have 10 to the 9 times 10 to the 6. But I need to move this decimal over one space because I want one digit in the front. When I do that, I've got 10 times, or 9 times 10 to the 5th. If I'm not sure, I could double check this a gazillion ways. I could say 0.9 times 10 to the 6th, and I get the same thing, 900,000, right? Well, I might say to myself, well, is that the same as 10 to the 5th power? 9 times 10 to the 5th power? Yep, it is. Okay. Yes. Okay. Good talk. Good talk. All right. So for step 1, it says combine the answers and rewrite it in scientific notation. So it's 9 times 5 or 9 times 10 to the 5th power kilometers per year. Then you could work backwards to double check your work. Now, we had some really big numbers, but doesn't this look so much easier to work with? Right? So, and these are types of calculations that physicists, people that work at NASA, actually do. Right? So they actually make these calculations, and when they generate their report, they could have these crazy long big numbers, or they could just, have 9 times 10 to the 5th kilometers per year. And that's why it's called scientific notation, because we use this in science when we measure really big things versus really small things. Any questions?